On today's episode, 2 important developments in nuclear energy. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. The fortunes of the civilian nuclear industry have ebbed and flowed with the political tides for 60 years now. Touted in the 1960s as a power source that would create electricity that was too cheap to meter, the industry was excoriated by the environmental movement in the 1970s and 80s and suffered the worst possible press in the wake of the Chernobyl and Fukushima disasters. In the 2020s, however, nuclear is re-emerging with the need to create large-scale dispatchable power to replace fossil fuels. Environmental concerns expressed by detractors 30 years ago are being addressed with new reactor technologies, and both governments and private enterprise are working on clean, safe nuclear solutions with urgency. 2 important developments are happening right now, one in China and one in the US. In China's Shandong province, the Shandong Nuclear Power Company has started supplying district heat to buildings in Dalian City, with supply increasing by the end of the year to 100% of that city's heating needs. The system uses 2 Westinghouse AP1000 reactors, extracting non-radioactive steam from the reactor's secondary cooling loop, which is then fed into a multi-stage heat exchanger, where heated water is pumped through municipal supply piping to consumers. According to World Nuclear News, the project is expected to replace 23,000 tons of coal annually and reduce carbon dioxide emissions by 60,000 tons per year. The system also generates power, taking advantage of waste heat rejected from the 2 Haiyang units, which provide about 20 terawatt-hours electricity to the grid annually. It's about 1/3 of demand in Shandong province. 6 reactors are planned for the site in total. Now, in America, a different kind of nuclear project faces a new challenge, one that is neither technical nor environmental. Utah's Carbon-Free Power Project is a consortium of municipal power systems who intend to purchase carbon-free energy generated by a new small modular reactor design built by NuScale, which is currently under development at the Idaho National Laboratory. Demonstration NuScale reactors are developed with the Department of Energy multi-year cost-sharing grant of $1.4 billion, subject to an annual appropriations process in Congress. And congressional support is key to the project. As reported by Utility Dive, inflationary price increases on steel combined with higher interest rates are increasing the cost of the project, which is expected to use a half a dozen 77-megawatt reactors, with the first coming online in 2029. Previous cost estimates for the project projected power priced at $58 per megawatt hour, but some estimates now run as high as $100 per megawatt hour as costs escalate. The $58 per megawatt-hour price is a key benchmark, and participating utilities have the option to abandon the project or renegotiate terms if costs exceed this amount. Now, it appears likely that the costs will exceed this limit, even with billions in tax credits for clean energy through federal legislation. Participating utilities will have until 2024 to leave the project, after which utilities are locked in contractually. The 2024 timeline is dependent on the Nuclear Regulatory Commission's review of this project. If utilities begin to drop out of the project due to cost escalation, NuScale's development program will likely depend on increased federal funding, something which is uncertain with Republican control of the House of Representatives. From an engineering perspective, the reactors look very promising. NuScale's technology promises to deliver carbon-free power with none of the traditional complexity, high operating cost, and safety issues of conventional large-scale reactor designs in a truck-transportable modular system. Carbon-free dispatchable power may still be attractive at pricing higher than $58 per megawatt hour, but no one knows what the energy market will look like by 2029. Will Congress fund the project to get these small modular reactors up and running? Time and inflation will tell. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.